Welcome, curious minds, to the Genius Propensity Podcast. Today, our journey focuses on Isaac Newton. In the annals of intellectual history, Sir Isaac Newton stands a colossus, a polymath whose insights reshaped the very fabric of our understanding of the universe. Born on December 25th, 1642, Newton's brilliance traversed the realms of mathematics, physics, astronomy, alchemy, theology, and literature. Newton's magnum opus, Philosophia Naturalis Principia Mathematica, unveiled in 1687, was the lodestar of the scientific revolution. In its pages, he forged the laws of motion and universal gravitation that reigned supreme until the advent of relativity. His revelations extended beyond the ethereal, embracing the practical. Newton, with a stroke of genius, crafted the first practical reflecting telescope, unveiling a cosmos previously unseen. Newton's Principia dismantled doubts about the heliocentricity of our solar system. With mathematical precision, he derived Kepler's laws, unraveled the mysteries of comet trajectories, and charted the ceaseless dance of celestial bodies. The geodetic measurements of Mopterius and La Condamine later vindicated Newton's assertion that Earth is an oblate spheroid. His laws embraced both terrestrial and celestial realms, creating a seamless cosmic narrative. Beyond celestial mechanics, Newton's inquiries into light illuminated a new path. The Optics, published in 1704, showcased his theory of color. By dispersing white light through a prism, Newton revealed the vibrant spectrum that paints our world. His experimentation extended to empirical laws of cooling, theoretical calculations of sound speed, and the introduction of the Newtonian fluid, an indelible mark on the science of his era. Newton's mathematical prowess knew no bounds. From calculus to power series, binomial theorem to cubic plane curves, his contributions reverberated through the halls of Trinity College and the University of Cambridge, where he held the prestigious Lucasian professorship. His academic devotion, however, harbored a complex tapestry. A devout yet unorthodox Christian, Newton privately questioned the Trinity. Despite refusing holy orders, he navigated political waters, serving as a member of Parliament and earning a knighthood from Queen Anne. Newton's insatiable curiosity transcended the known. Delving into alchemy and biblical chronology, he dedicated untold hours to these esoteric pursuits. Much of his work remained hidden, awaiting discovery, long after his departure from the mortal realm. As Warden and Master of the Royal Mint, Presider of the Royal Society, and a luminary in London's intellectual circles, Newton's final 3 decades were a testament to his enduring influence. Sir Isaac Newton, a beacon of enlightenment, a virtuoso of the cosmos, and an architect of the scientific edifice that continues to stand tall. As the pages of history unfurl, we dive into the early life of Isaac Newton, a child born amid cosmic happenstance, destined to unravel the secrets of the universe. Newton's journey commenced on Christmas Day 1642 at Woolsthorpe Manor in Lincolnshire, England. Born prematurely and diminutive, Newton's entry into the world was marked by the absence of his father, who had departed 3 months earlier. His mother, Hannah Ayscough, remarked that he could fit inside a quart mug. Newton's early years were shaped by familial twists. He disliked his stepfather, the revered Barnabas Smith, harboring resentment towards his mother for this union. Amid familial complexities, Newton's academic odyssey began at the King's School in Grantham. From sundials to windmill models, he excelled, becoming the school's top-ranked student. His intellectual vigor propelled him back to academia after an attempt to mold him into a farmer, an occupation he loathed. In June 1661, Newton embarked on a new chapter at Trinity College, Cambridge. Initially a sub-Caesar, he worked as a servant, earning his keep. Yet his pursuit of knowledge did not go unnoticed. His uncle's recommendation, coupled with his academic prowess, earned him a scholarship. Cambridge, steeped in Aristotelian teachings, witnessed a transformative tide with Newton's arrival. Alongside the ancient philosopher's wisdom, Newton delved into the works of Descartes, Galileo, and others. He set forth his Quaestiones in a mechanical philosophy, laying the groundwork for his later triumphs. In 1665, the spectre of the Great Plague loomed, prompting the temporary closure of Cambridge. Newton retreated to Woolsthorpe, his home, initiating an intellectual renaissance. Over 2 years, he birthed theories on calculus, optics, and gravitation. Newton's return to Cambridge in 1667 heralded a new era. Elected as a Fellow of Trinity, he was on the brink of a spiritual crossroads. The stipulations of the Lucasian professorship, theological ordination, clashed with Newton's burgeoning scientific fervour. A delicate compromise spared him from priesthood, enabling him to ascend to the Lucasian chair in 1669. Newton's academic brilliance beckoned royal acknowledgement. In 1672 he was elected a Fellow of the Royal Society. His ascendancy continued, succeeding Isaac Barrow as the Lucasian professor just a year after receiving his M.A. Newton's tenure at Cambridge was marked by intellectual vigour, aligning with the tenets of the Royal Society. His unorthodox views, a harbinger of future conflicts, managed to navigate ecclesiastical scrutiny, sparing him from the demands of Anglican orthodoxy. Isaac Newton, a prodigious mind, straddled the realms of academia, theology, and science, and he was poised to etch his legacy into the annals of the Enlightenment. In the midst of his illustrious career, Newton's intellect touched every facet of mathematics and science, leaving an indelible mark on the annals of knowledge. Newton's mathematical prowess was a beacon in the realm of calculus. His manuscript of October 1666, known as Fluxions, or Calculus, showcased his extraordinary genius. A letter from Isaac Barrow to John Collins hailed it as the work of an exceptional mind. However, the Leibniz-Newton calculus controversy cast a shadow over his achievements. The dispute of a priority with Leibniz, despite modern historians' belief in independent development, marred Newton's reluctance to publish his calculus. The Royal Society, inflamed by accusations of plagiarism against Leibniz, declared Newton the true discoverer in 1711, initiating a bitter feud that persisted until Leibniz's death in 1716. Beyond calculus, Newton's mathematical ingenuity extended to the generalized binomial theorem, Newton's method, finite differences, and groundbreaking work on infinite series. Newton's exploration of optics heralded revolutionary insights. His seminal work in 1666 on the spectrum of colors refracted by a prism challenged existing paradigms. Unlike prior beliefs, Newton asserted that color was intrinsic to light, not an external property. From 1670 to 1672, Newton delved into optics, unraveling the mysteries of light's behavior. His lectures revealed that a prism's multicolored spectrum could be reconstituted into white light using lenses and a second prism. Newton's theory of color posited that objects interact with colored light, challenging previous notions. In his quest for optical perfection, Newton identified chromatic aberration in refracting telescopes. To overcome this, he devised the first functional reflecting telescope in 1668, using mirrors instead of lenses. This Newtonian telescope, presented to the Royal Society in 1672, reshaped astronomical observation. Newton's corpuscular theory of light posited particles as the carriers, although wave theories gained prominence later. His work laid the foundation for future developments in optics, influencing the understanding of light's wave-particle duality. Newton's celestial odyssey reached its zenith with his theory of gravitation, conceived as early as 1665. Returning to celestial mechanics in 1679, Newton grappled with gravitation's impact on planetary orbits. The appearance of a comet in 1680 to 1681 spurred Newton's correspondence with John Flamsteed and fueled his astronomical pursuits. His seminal work, De Motu Corporum in Gyrum, laid the groundwork for the Principia, published in 1687. The Principia, a magnum opus, enunciated the 3 laws of motion and unveiled the law of universal gravitation. These laws became the bedrock of classical mechanics and propelled technological advances during the Industrial Revolution. Newton's heliocentric view of the solar system and his definition of gravity as gravitas reshaped scientific paradigms. Newton's postulate of an invisible force acting over vast distances, despite criticism for introducing occult agencies, stood firm. In the general scholium of the Principia, he defended his approach, asserting that hypotheses should align with phenomena. With international recognition, Newton's influence extended beyond mathematics and science, leaving an indelible legacy for generations to come. Newton's later years were a tapestry woven with religious writings, political engagements, and administrative responsibilities, further enriching the narrative of his remarkable life. In the 1690s, Newton ventured into religious tracts, exploring the interpretation of the Bible. His manuscripts, disputing the fidelity of the Johannine comma, remained unpublished until 1785. Newton's engagement with theology demonstrated a multifaceted intellectual curiosity extending beyond the realm of mathematics and physics. Newton's involvement in the political arena was marked by both notoriety and humour. As a member of the Parliament of England for Cambridge University in 1689 and 1701, anecdotes suggest his parliamentary contributions were minimal, with complaints about a cold draught and ghostly rumours. Nevertheless, his position didn't dampen his dedication to public welfare. Newton's move to London in 1696 marked a pivotal shift in his career as he assumed the role of Warden of the Royal Mint. Tasked with England's recoining, Newton undertook the challenge seriously. His efforts during the Great Recoinage exposed rampant counterfeiting, leading to convictions and tangible reforms. Newton's pursuit of justice took him undercover, infiltrating bars and taverns to gather evidence. Despite the barriers to prosecution, his authority as a justice of the peace empowered him to conduct over 100 cross-examinations. His resilience resulted in the successful prosecution of 28 coiners, showcasing his tenacity. Newton's eminence in the scientific community reached its pinnacle when he became the president of the Royal Society in 1703. However, this tenure wasn't devoid of controversies. His premature publication of John Flamsteed's work strained relations with the Astronomer Royal. Newton's influence expanded internationally as he became an associate of the French Académie des Sciences. Queen Anne knighted Newton in 1705, a move perceived as a politically motivated one. In his later financial investments, Newton faced challenges. His involvement with the South Sea Company resulted in significant losses when it collapsed around 1720. Toward the end of his life, Newton found solace at Cranberry Park near Windsor, residing with his niece Catherine Barton and her husband. His retreat from public life contrasted with his earlier pursuits. Newton's death on 20th of March 1727 marked the end of an era. A ceremonial funeral at Westminster Abbey honoured the man whose brilliance had reshaped science. He was the first scientist to find a resting place among kings and queens in the Abbey. Newton's legacy transcends science. His intellectual breadth, from mathematics and physics to theology and administration, solidified his status as a polymath. As the pages turned on his life, Newton left an enduring legacy that continues to inspire generations. As we conclude our immersive journey through the intricate tapestry of Isaac Newton's life, we invite you to delve deeper into the ever-unfolding narrative. If you found this documentary enlightening, consider supporting the creation of more educational content by liking, subscribing, and joining our Patreon at patreon.com/geniuspropensity.